Welcome to Emilak Online Tutorial. Now before us is this question in elasticity, and it says the force of 40 Newton applied at the end of a wire of length 4 meter and diameter 2.00 meter process an extension of 0.24 millimeter. Now calculate the stress, the strain, and the Young modulus, and we're given that pi equals 3.4. Okay, now let us recall that stress in itself equals to the force all over area, and strain equals the extension all over the original length, and 3 the Young modulus in form of gamma is equals to the ratio of the stress to that of the strain. So with this given formula, now we will be able to calculate these three given terms. Now, but before we do that, let's note here that the force F now from the question is 40 Newton. Now our area here is not given, but we need to sort out how well to solve this area. Now, but from the question we are told that the wire, let us assume the shape of a wire which is in this shape of a cylinder. Okay, so so it takes the shape of a circle. So, and we know that the area of a circle is pi r square. Okay, and from the question we are told that pi is 3.14, then times, now the radius is not given, but we are given diameter, and we know that diameter equals 2r, right? Okay, and to this end we can make r the subject of relation. That would be d diameter all over 2, which means diameter divided by 2, and here we have a 2.00 millimeter all over 2, and our radius will be 1.00 millimeter. But take note, we also need to convert this unit millimeter to meter, and as such, let's take note, for just using a short format, we can either divide 1 by 1000, or milli here implies 10 raised to the power of 3. Okay, so our radius is now 1.00 times 10 raised to the power of minus 3 meter. Okay, so to this end here we can see our area will be 3.14 times 1.00 times 10 raised to the power of minus 3, all raised to the power of 2, right? Okay, so in that stand we can see here that force is 40 all over 3.14. now 1.00 times 10 raised to the power of 3 all raised to the power of 2 will give us times 1 times 10 raised to the power of minus 6, and this is the fact that 1 raised to the power of 2 is 1. Now 10 raised to the power of minus 3, now according to the law of indices we will need to multiply the power, which implies minus 3 times 2, which are giving us negative 6. So this will definitely give us 40, then times, now we can just bring 10 to the power of 6 to the numerator, then it becomes 10 to the power of 6, sorry, 10 to the power of negative 6, bring it to the numerator, it becomes 10 to the power of 6. Now all divided by 3.14. Okay, Now if I to punch our calculator here, we have that 40 divided by 3.14. So we have it will be 12.7 times 10 raised to the power of 6. So here will become 1.27, then times 10 raised to the power of 7. And our unit is in Newton per meter square. Okay, right. Now for the strain, we have our extension to be 0.24 millimeter. Now converting millimeter to meter, I said earlier that our milli here implies 10 raised to the power of -3 or -3. So here converting it to meter, we now multiply this by 10 raised to the power of -3 all over. The original length is given as 4. Okay, so we can round this off by saying, or 0.24 can be also rewritten as 24. Now take note, let us just bring this decimal to display. That will be 1, 2. So here you have 10 raised to the power of -2, then times 10 raised to the power of -3 all over 4. Now 4 here, 1, 4 in 24, you have 6. So our final answer here will now be 6 times 10 raised to the power of -5, because -2 plus -3, according to the law of indices, we have to add the power to give us 5. Now since strain is a ratio of extension having a unit of meter and length having a unit of meter, so it is unitless, so it has no unit. All right, so and that is that. So let us now solve the Young modulus. Now Young modulus is the ratio between stress and strain. Now for the stress, we are given it is 1.27 times 10 raised to the power of 7. Now all over, then 6 times 10 raised to the power of -5. Well, that is strain. So here we can do this, the 1.27 divided by 6, now times 10 raised to the power of 7. Now by division, we have -5, right, according to the law of indices. So 1.27 now divided by 6, that will give us 0.211, approximately 7, then times 10 raised to the power of, here we now have 7 plus 5, and that should give us 12. So here we have what? 12. Okay, now the final answer, and this will give us in Newton per meter square, and it takes the unit of stress because strain doesn't have a unit. All right, so this is our final answer, and this is the solution to the problem. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in mathematics and physics. Thank you and God bless you.